The rocket is a unique high-speed evaporation system specifically for the evaporation and concentration of large volumes of solvent. The speed and functionality of the rocket evaporator and its accessories provides significant work savings in the laboratory. The latest Rocket Synergy series offers the unique flexibility of interchangeable rotors, enabling processing of a wide range of sample volumes in a single system. When fitted with a removable 6-position flask rotor, the Rocket Synergy will accept up to 6 flasks with a working volume of 400 milliliters or up to 18 ASE tubes with options to optimize sample transfer. Replace the flask rotor with a stainless steel evaporation vessel or bowl rotor, and the Rocket Synergy is capable of larger volume batch processing of up to 5 liters. To concentrate or evaporate a sample to dryness, the traditional method has been to boil the sample. Boiling uses heat energy to convert liquid to vapor, which appears as bubbles. The problem with regular boiling is that it may damage the sample. Genevac have perfected a system that rapidly concentrates the sample without causing damage. The sample still boils, but it boils at a low temperature, preserving the sample. Low temperature boiling is achieved by reducing the pressure in the evaporator. Reducing the pressure reduces the boiling point of a liquid. Water boils at 100 degrees centigrade at atmospheric pressure. At 6 millibar, water boils at 0 degrees. Reduce the pressure still further and water will boil below 0, creating a freeze dryer. The temperature of a boiling liquid cannot increase above its boiling point and is therefore very stable. With just a vacuum, bubbles would still develop in the sample, whatever the set temperature. Bubbles in a tube will force liquid out. To prevent samples boiling over, a centrifuge is used to create a pressure gradient in the tube and ensure that the sample boils at the surface of the liquid. Because Genevac's evaporators can handle multiple samples, the effects of boiling over or bumping would be catastrophic. Genevac's dry pure system is used to control bumping and eliminate its effects. The patented dry pure system applies a high G-force at over 500 times gravity to the samples. At the same time, the pressure is slowly reduced so as to carefully control the boiling process. All Genevac evaporators are equipped with technology to directly monitor and control the temperature of the samples inside the system, ensuring samples are not exposed to harmful temperatures. The pressure inside the evaporator is accurately controlled at all times so as to optimize performance and ensure efficient collection of the solvent vapor in the cold trap. The cold trap recovers and condenses the solvent vapor, preventing harmful emissions. Solvents can then be disposed of appropriately, leaving you with the perfect sample. To achieve very fast evaporation while maintaining sample integrity, the rocket has an innovative patented heating system. Infrared heat lamps or water baths are used by many traditional technologies. The rocket uses steam. To ensure safety, the steam is at low pressure and low temperature. The flasks or vials are sealed into the rotor. The body of the flask is exposed to the steam, but the mouth is kept separate in the inner chamber. Vapors exhaust to the cold trap via the center of the rotor. In cross-section, there are 2 chambers: the inner chamber where the solvent evaporates, and the outer chamber where steam is created. Deionized water is used in the outer chamber to create low-temperature steam. The vacuum is used to control the boiling point of water to the temperature set by the user. To ensure that the system cannot overheat, the whole chamber is also controlled at the set temperature. Steam condenses on the sides of the flasks, but because the samples are boiling under vacuum, they remain cold. Condensed water is thrown off the walls of the flask because of the G-force acting on the rotor, keeping the wall of the vessel clear at all times. The rocket contains a fully optimized heating arrangement. The energy released by condensing steam is massive, yet controlled at a safe temperature. The rocket evaporation system is designed primarily for large volume, parallel evaporation. The samples are spun, and as they boil, vapors are drawn to the cold trap, which condenses the vapors to a liquid. A remote chiller is used to cool the cold trap. Alternatively, coolant from a ring main may be used. The vacuum is provided by a robust, oil-free, solvent-resistant vacuum pump. The system is operated via the simple controls. A built-in strobe lamp enables each sample to be viewed separately and in real time during the evaporation process. Your local Genevac representative can help you optimize and load new or updated methods to your system. Using the rocket is simple. Load your flasks or pucks of tubes into the rotor. Secure the inner lid. Check the water level. In normal operation, the rocket will need an addition of less than 50 milliliters of water per day. Close the outer lid and select the appropriate method. Set the maximum safe temperature for your samples and hit start. The system will evaporate the samples automatically, leaving the operator free to do other things. Dry pure, pressure and temperature are all accurately controlled by the system, stopping automatically when the samples are dry. The cold trap collects the vapors, condensing them to a liquid. You can monitor the progress of evaporation using the delta T graph that calculates the difference between the coolant temperature entering and leaving the cold trap. When this value approaches zero, evaporation is close to an end. The strobe may also be used to directly monitor progress. When the system stops, open the lids and remove your samples. The rocket takes 33 minutes to evaporate 6 flasks, each containing 250 ml of hexane. The system has an automatic draining cold trap, so it's ready for the next user. If you need to concentrate your samples rather than dry them, the standard methods can be optimized by your local Genevac representative. The operator may also fine-tune the methods on the system. In some cases, the addition of a solvent keep is necessary to ensure that the samples remain wet. The evaporation method is then set to evaporate the more volatile solvent, leaving the keep solvent behind. Alternatively, Sample Genie may be used with a concentration adapter. Sample Genie enables a large volume to be concentrated directly into a GC auto sampler vial. The design of Sample Genie means that the vial is insulated from steam, and therefore the solvent of the vial does not dry, only the solvent in the flask. A similar system is available for users of ASE vials. The double-ended flip-flop tube is used to collect the extract from the ASE system. Insert a GC vial into the flip-flop funnel and attach to the top of the flip-flop tube. Flip the tube over, remove the second cap, and place into the rocket. When concentrated, the sample is contained in the GC vial. The flip-flop system has eliminated the need for sample transfer. The rocket synergy can also be used in batch mode to evaporate solvent loads of up to 5 liters. Remove the flask rotor and replace with the 316 stainless steel vessel or bowl rotor. Fit the baffles, add the product and close the lid. Check the water level. Select the appropriate method and hit start. The system then controls the evaporation process, draining the condenser periodically and stopping when complete. Dry samples can easily be scooped out. Alternatively, they can be redissolved in situ in a minimum volume of solvent and recovered as a concentrate. The solvent added, the rotor agitates for a user-controlled time to aid dissolution. Recovering liquid samples is simple with the vessel drain stand. The vessel has a drain port fitted. Now you don't need to choose between flask or batch evaporation. The Rocket Synergy evaporator will accommodate your process whatever the volume. For more information on the Rocket Synergy, contact Genevac today.